So what I wanted to look at today was proving what's written here. Cosine of x minus y equals cosine of x times cosine of y plus sine of x times sine of y. So I'll get to that in a second, but obviously you can see we've got a bit going on here with our unit circle. So that's the first thing to point out, is that what we have drawn here is a unit circle. And just a few things we want to be clear on. The first is that this angle in here is just y. So this arc, A to B, is subtended by an angle equal to y. And this angle all the way around from, our x-axis all the way around to this point is the angle x. Okay, so that's the first key point we need to be aware of, just because it's hard to get the shadings of the colors right. And the next thing we want to say is, all right, let's have a think about what is this angle here. Well, if all the way around is x and then this first part of it is y, then hopefully you can see then this angle here must be x minus y. That angle there is x minus y. Okay, and so what we're actually going to do is we're going to make a rotation. I'm just going to get rid of that for a second, but you've got to keep that in mind. Actually going to make a rotation, so let's make a movement. So let's take this sort of sector, and I want to rotate it around a point. I'm going to rotate it around the origin. I'm going to rotate it 45 degrees clockwise. Now, the angle y there is actually 45 degrees. I need to pick some angle to do the demonstration, but this works for any angle, and what we're trying to do is to prove this generally. If I press OK, you can sort of see an outline of a new sector there, but I'm also, before I change the color of that, I'm just going to rotate this line as well. So let's change this line to rotate around a point. It's already on that. If I click there, rotate it 45 degrees clockwise. Okay, so let me just change the color of this second sector that we've made. Let's change that to a different color. Let's go with orange. Okay, to make things a bit clearer. Okay, so let's also just rename some of these points. Let's call this P. And I'm not sure why this changed. Let's call that A again, because that's important. If I could change that to A, that would be good. Okay, let's call that point A. So that looks good. Okay, so there's a few things that you might notice. What we've actually got is we've got two triangles. So we've got this triangle. Let's call this origin here O. So this is the origin O. We've got a triangle. We've got OCB and we've got OPA. Now, what we said before is we just sort of took this sector and we rotated it and placed it sort of on the x-axis. So we remember from before that this angle here now is going to be angle x minus y. We sort of took that from what we said before and we just shifted it. Okay, so that must mean that this point P here, which was at C, has been shifted over. So this now must be at cosine x minus y. And it's not very good drawing on this. Cosine x minus y, and then sine x minus y. So that's the coordinates of the point P. So let's do that a little bit better. Okay, so that's interesting, because what we can prove now is hopefully start to get a feel for proving the double angle formula. So what we've got at the top here is we can say that triangle OCB is going to be congruent to, is the exact same triangle as triangle OPA. And hopefully you can see why that's the case. We've just literally shifted those triangles across. And so that must mean that this red dashed line, CB, is equal to the other red dashed line, which is PA, because those triangles are congruent. Okay, now what we want to do is we want to talk about the length of CB. So what is the length of that line CB? And the way we're going to do that is we're going to use Pythagoras' theorem, essentially, the distance formula for the distance between points. So if we just take a little aside here and look down here, let's imagine we've got a point A and that has coordinates A, B. And we've got another point B, which has got coordinates C, D. If we wanted to know the distance between points A and point B, well, we'd need to know the horizontal distance and the vertical distance between those points. So the horizontal distance is going to be C minus A, and the vertical distance is going to be D minus B. So the horizontal distance here is C minus A, and the vertical distance is D minus B. And then we're just applying Pythagoras' theorem. C squared equals A squared plus B squared. Or in this case, we can say the length AB squared is equal to C minus A squared plus D minus B squared. Hopefully you can see where that comes from. And that's just our distance formula for distance between two coordinates. And so what we're going to do now is we're going to say, all right, what is CB squared, or what is the length of CB essentially? Well, we can write that down in terms of the coordinates. So cosine X minus cosine Y is the horizontal distance between the points. We have to square it, and then plus the vertical distance between the points, which is sine X minus sine Y, and then we square it. So hopefully you can see where that comes from. So CB squared is equal to that. And then if we just do a careful expansion, we can see that CB squared equals 2 minus 2 multiplied by cos of X times cos of Y plus sine of X times sine of Y. I encourage you to get out a piece of paper and just check that works. But remember expanding out your binomials correctly and then collecting any like terms. That's how you'll get that to work out for you. Okay, and then we're going to do the exact same thing with PA. So we're going to do PA squared. Okay, so PA squared, again, we know that the x value at this point is going to be cosine of X minus Y. So it's cosine of X minus Y minus 1, because that's the horizontal distance between these points. That's sort of this distance here. Okay, plus and then we square that, and then plus the vertical distance squared. Well, the vertical distance, well, that's just sine of X minus Y squared. And then we expand that. We do the same thing. We expand it out. Careful to, when you expand it out, to use correct binomial expansion. And then we know from before that CB equals PA. So CB squared equals PA squared. We can just drop the square roots. And then our final conclusion, and I encourage you, it feels satisfying. You just rearrange some things, and you can probably see how those things will fall out, because we're saying this thing is equal to this thing, right? Well, the 2's on both sides will cancel out. And then we're going to divide both sides by 2. And so you can see they're going to be left with cosine of X minus Y equals cosine of X times cosine of Y plus sine X sine Y. And so that is the derivation of our double angle formula. And that's just one of our double angle formulas, but sort of the insights that you get from this one can help you solve all the other double angle formulas that you'll come across in the courses that you study. So hopefully that clarifies the double angle formula.